इस वीडियो में हम टाइम कन्वोल्यूशन प्रॉपर्टी स्टडी करेंगे, डिस्कस करेंगे। आपको वीडियो पसंद आएगा, आप लाइक करिए, शेयर करिए, चैनल को सब्सक्राइब करिए एंड डू नॉट फॉरगेट टू प्रेस द बेल आइकन। टाइम कन्वोल्यूशन प्रॉपर्टी we can define if we know the Laplace transform of x1, which is a function of time, is equal to x1, and we also know the Laplace transform of x2, that is equal to x2. That's how we can define it. Then the definition of time convolution property is x1 convolved with x2, both are the function of time, और इसका अगर हम लाप्लास लेते हैं तो that will be equal to x1s multiplied with x2. That's how we can define it. The proof of this is this: we are assuming that both the signals are causal, and for causal the convolution definition is going to say that if both are causal, means the value defined when t is greater than or equal to 0, so it may be defined like this for two infinite signals. D tau. So that is by definition of convolution, and now by definition of Laplace we can write it x1 t convolved with x2t, that is the integration from 0 to infinity x1 t convolution with x2t in the bracket. By definition of Laplace we can multiply with e raised to the power st and dt. By definition we can write. And about the definition of convolution as defined in the equation number 1, we can write integration from 0 to infinity x1 tau and x2 t minus tau d, not d, e raised to the power minus st d tau and dt. That's how we can write it. Now let for integration, let t minus tau is equal to some dummy variable p. Then take the derivative, then dt is equal to dp. If it is so, then this above equation can be written as the integration from 0 to infinity x1 tau integration from 0 to infinity x2, we can take it as a p, and e raised to the power minus, now it is t, so it is p plus tau, so we can write this is p plus tau, right, into s. That is equal to d tau and dt is equal to dp. So if it is so, then we can further write is integration from 0 to infinity x1 tau integration from 0 to infinity, we can write it x2 function of p, we can write e raised to the power sp and e raised to the power minus tau s d tau and dp. Now by the definition of Laplace, we can rewrite the term like 0 to infinity x1 tau integration from 0 to infinity. Now x2 p e raised to the power minus sp and here we can write dp. So this is by definition of Laplace, and e raised to the power minus tau s and d tau. So that's how we can define. So it will be by definition 0 to infinity x1. By definition we can write this as x2. We can write x2 as x2s and e raised to the power minus tau s and d tau. That's how we can define. And because it is d tau, so we can take x2s here, and rest of the term is 0 to infinity x1 tau and e raised to the power minus tau s and d tau. That's how we can write it. And finally, this is by definition of Laplace, so we can write x2 s multiplied by x1. So that's how we can write the convolution of two signals in time domain is equal to the multiplication of two signals in frequency domain. So we can have another context in that also. We can also try an example for this. So that is, so we have an example here. So we can consider that if x1, given statement is x1, which is a function of time, is equal to e raised to the power minus 2t ut, and x2 in time domain also is given by e raised to the power minus 3t ut. So two signals are given in the time domain. Now we have to determine ys. We have to determine ys, that we have to determine. So in that case, yt is also given here. We know the yt, which is given by the equation, that is x1 t minus 2 bracket close x2 minus t and plus 3. That's how it is given. Now to find out x1 s, this is nothing but the Laplace of x1, where x1 is defined by the term e raised to the power minus 2t ut. Now the Laplace of this will be 1 over s plus 2. Now we have to find out x2s. Again, this is nothing but the Laplace of e raised to the power minus 3t ut, which is x2. So it is given by 1 over s plus 3. So that's we know. Let x1, let x is equal to x1 t minus 2, and we also know h t, that is equal to x2 minus t plus 3. So that's by these two terms we know the value of x and h. So by definition of convolution, we can have that yt, output or the time response, is the convolution of input, convol convolution of input and the impulse response of the system. Now we can find out the xs here. Xs, for that, it is a Laplace transform of x1 t minus 2. By using the shifting property, we can write it e raised to the power minus 2 s 1 by s plus 2. So that's we know कि हमारे पास अगर x हमने निकालना हो तो this is the formula, because we already know that what is the Laplace of x1 s. What is x1? So we can calculate it is t minus 2. It is because of the time shifting. Directly we can apply the time shifting property and we can find out. Now the another is we have to calculate hs. So hs is nothing but the Laplace of x2 minus of t and plus 3. So this is the time reversal of xt and shifted right by 3 units. So that is the understanding of this. This is time reversal and this is right sided shifted by 3. So for that one, we can calculate the time reversal property of this कि हमें x2 का निकालना है जो कि टाइम शिफ्टेड सिग्नल है, and we already know the value of xt. x2 t is e raised to the power minus 3t. फाइन. सो अगर टाइम रिवर्सल होगा तो हम उसको रिप्रेजेंट करेंगे by the property of time reversal x2 minus s. If it is so, तो हमने यहाँ पे ऑलरेडी x2 का निकाला हुआ है, तो इसमें हम क्या करने वाले हैं? We are going to put minus s in place of plus s. That is with the property of time reversal. Now we have to shift it by 3. So we are going to use the time shifting property to calculate hs. So that is the Laplace of x2 minus t plus 3. So we are using time shifting property here. That is equal to e raised to the power minus 3s. Now already हम फोल्डिंग कर चुके हैं, इसकी टाइम रिवर्सल प्रॉपर्टी लगा चुके हैं, तो इट इज कम्स आउट टू बी x2 minus s. ऑलरेडी हमारे पास ये सिग्नल था. नेक्स्ट स्टेप में हमने ये कैलकुलेट करना है. नाउ वी कैन पुट द वैल्यू दैट इज e raised to the power minus 3s and the value of x2 minus s is 1 over s plus 3. So that's how we can calculate it. Now at the end we have to calculate ys, which is the product of xs and hs. So what is xx? We already calculated, it is this quantity. That is e raised to the power minus 2s 1 over s plus 2, and the another term we are having for hs is this term. So we are having e raised to the power 3s, divide the complete term s plus 3. दोनों को solve करेंगे हम, and we can directly write it also. No issue. So rather to go into the depth, you can also write it e raised to the power minus 2s, divide the complete term s plus 2. This is in one bracket you can write, and another is e raised to the power minus 3s, divided by s plus 3. So that's how you can use the property and find out the response of a given system. Hope you like the video. Please subscribe the channel.